Welcome everyone, my name is Aaron Van Wirdum. I work for Bitcoin Magazine and this is the panel on smart contracts. I'll let the panelists introduce themselves. Let's start with Adam.
Yeah, I'm Adam, co-founder of Blockstream.
Yeah, I think that's plenty of introduction. For everyone knows who Adam is.
Hi, my name is Olga. I work at LNPBP Standards Association. We work at layer 2, 3 technologies. One of them is RGB, which is probably the most famous one so far. I'm also a co-founder of a Pandora Prime project, Pandora Prime company, where we develop user-facing tools based on top of the protocol layer developed in the association.
Yeah, and Olga, you're replacing Maksim, who was scheduled to be on this panel.
Yeah, he replaced me yesterday. I'm replacing him today.
Right, and Adam is replacing Sirion. Just so everyone knows why there's different people on the panel compared to the agenda.
Hi, I'm Daniel. I'm part of the commit team. We have been working on non-custodial trading solutions for a while and recently started building Ichisats, which is non-custodial trading solutions using DLCs, discrete lock contracts, directly on the Bitcoin blockchains. It's a CFD, like a derivative solution.
Hello, I'm Marco Argentieri. I'm head of products at Vulpem. We do a lot of R&D development on Bitcoin and Liquid, and a lot of governance research lately.
All right, so the panel is about smart contracts. So let's start at the beginning, because maybe there's people in the room that don't know, or maybe there's also difference of opinions of what it actually is. So what is a smart contract? How would you guys define a smart contract?
So I'd say it's a small predicate or program that you can attach to a Bitcoin electronic cash that governs how it can be spent. And using that, you can go beyond just spending electronic cash to representing simple contracts for, I don't know, different kinds of use cases around trading or outcomes.
So does Bitcoin currently have smart contracts under this definition?
Yeah, I mean, I think you want smart contracts to be secure and safe, and Bitcoin's contracts are that, where other altcoins have imported extremely complex virtual machines and JavaScript-like languages and have become extremely unsafe. And so, yeah, Bitcoin has had smart contracts from release, and many of the things in Bitcoin are effectively smart contracts, like multisig is a simple smart contract, Lightning is a smart contract with hash locks, and there are lots of different use cases involving Bitcoin contracts, and some people on the panel mentioned other ones like DLC-based Bitcoin smart contracts.
Yeah, does everyone agree with this definition? Is this what a smart contract is? Or?
Oh, I can probably add up to that. I'm just a bit afraid that Adam will just smash my not knowledge of smart contracts. So from what I know, the term itself was coined not specifically for the blockchain industry or environment. It was introduced by Nick Szabo, right?
Nick Szabo, yeah.
Yeah. It was back in the day, and it was not specific to blockchain industry or Bitcoin itself. And probably my definition is not as technical, but it's an agreement between parties which can still and will still be fulfilled without reaching out to a third party to enforce the fulfillment of the agreement or applying physical force.
Okay. Does that settle it?
Yeah, I think so. Maybe I can add, there are a couple of use cases interesting, and one in Bitcoin is how to move your Bitcoin, how to secure your Bitcoin. At the moment, we have, as Dr. Beck said, we have very secure contracts already, and with Taproot, we are very private contract. One thing I'm looking forward is definitely how to make more secure vaults for your Bitcoin, and definitely there is a lot of community involvement to try to push this.
Okay, so did you want to add something?
I would just a very tiny thing, because I think it should be mentioned that smart contracts were especially kind of driven by Ethereum and this word, and in Bitcoin, this is quite different. I think in one thing that is really important in Bitcoin scripts is that a lot of stuff is just off-chain. So like for me, smart contracts, when it comes to Bitcoin, are a lot about smart spending conditions and protocols around them and keeping a lot of things off-chain and not on-chain. And the on-chain footprint probably doesn't exist. And you have privacy through that as well, because you don't really can distinguish a smart contract on Bitcoin, which is basically often just an off-chain protocol, from anything else happening on chain.
Okay, so
May I follow up a bit there? I do agree with you that the term smart contract got like its popularity because of Ethereum, because Ethereum was the one who was driving the adoption of the term, at least. But of course, Ethereum-based industry, let me put it like this, they did more modular, I want to say, smart contracts, but they were not private, not secure, and Ethereum did a lot of experiments with smart contracts, and I'm very grateful for the whole industry for showing us how not to do smart contracts. And I'm flattered to actually now be on this panel because and see smart contract term being brought like back home, and us like having the possibility to do it the right way, the scalable way, the private way.
okay, so doing smart contracts the right way. But I think all four of you are thinking of different ways of bringing it to Bitcoin. So let's have an overview of your approach of bringing smart contracts to Bitcoin. Shall we start with Marco?
Yeah, definitely. On Liquid, for example, which is basically Bitcoin Core plus more opcodes, we can do the same contracts you can do on Bitcoin, but you can also do covenants. And covenants are what maybe they call stateless smart contract, in the sense that you are not writing or reading from the chain like Ethereum, but still you can like encumber how and where you want your Bitcoin or other assets to, for example, Liquid to be, to be spent in the future. And this allows you to do like smart vaults or more maybe financial application like options or futures or things like this. And I think like Liquid is a nice testbed on to move and try to test in real life application how the covenants, could evolve eventually on the Bitcoin main chain. We already had some proposal like in this year, but I guess, definitely on Liquid we already have just from Stack and Cat, two opcodes, and that allows you to do these complete recursive covenants. So maybe that will be one path forward and a nice testbed, right?
Okay, can you really quickly explain what a recursive covenant is?
Okay. The idea is that basically I can encumber a condition. As I said, a covenant is how and where your Bitcoin can be spent. Like I want to enforce that this Bitcoin can be spent to this address, and maybe just 0.1 of this after one-time lock. I don't know. I'm just making an example. And a recursive covenant allows you to encumber in another covenant. So basically, you're enforcing to go to an address. That address will be a covenant. So it will be maybe potentially infinite loop. And this allows smart vault construction, and which basically allows you even to lose all your keys. And you, for example, the smart vault construction proposed in the past allows you to basically go in an infinite loop with your attacker, and you always reset. And even if steals all your keys, you can still like prevent the attacker to steal your Bitcoin. So it increases much higher security.
And I think you mentioned this is enabled by Opcat and another opcode.
And check from Stack, yes.
All right.
On Liquid is live, so you can do that.
Opcat used to be on the Bitcoin main chain as well,
Right.
right? And check SIG from status, no?
No, has been proposed a long time ago, but it's never been on Bitcoin. Yes.
Do you know why Opcat was removed?
Because there was an overflow bug back in the day, so Satoshi decided to put it away. Cat is very fun because there was Andrew Polstra with his blog post. Basically, if just with Schnorr signature and Cat, nothing else, you can directly do covenants and more advanced construction. So I think in the community, Cat is very scary because it's very simple. It's like concatenating two strings, which is like, attaching those things together. Very simple, but there is a lot of things that we don't know, and definitely is very scary. So I think things like simplicity, for example, makes less scary to roll this kind of improvement to Bitcoin.
Right. And in your view, your vision is that these opcodes are sort of tested on Liquid as a test bed, and then eventually maybe make it back to Bitcoin or make it to Bitcoin.
Yes, the argument that testnet is there, but testnet has no value, so nobody's so excited to do real life experiment with coin that had no value. So a sidechain like Liquid is definitely the perfect spot where you can test your experiment with a bit of real value and see what user wants, how they want it. So maybe it will be nice information for the Bitcoin community to in the Covenants discourse.
Right. Well, that sounds interesting, but I know, Daniel, you have a better way of doing smart contracts. That's your position.
I wouldn't say a better way. It's just different. I think in the end, like I would go quite high level again from like the original question, as in like it depends on your use case. It depends what you want to do, and certain things can be done on like current Bitcoin with the opcodes we have available, and certain things just can't. And if you, for example, want to have an additional native tokens or like certain more privacy-focused transactions, certain like then you probably need something like Liquid. We actually built on Liquid before. I'm not sure if you know that, like, but I mean, we built a lending solution before that was based on Liquid, but eventually we came to the conclusion, wait a minute, with what's currently there and DLCs and looking more into discrete law contracts out there, we came to the conclusion, hey, we can actually do derivatives already on present day Bitcoin. So we just went for it. So, yeah.
What's the status of that? It's possible today?
It is possible,
is
yeah.
It
like
used today?
It is, yeah. I mean, we are live on mainnet, and it's even perpetual. It's a perpetual CFD solution, basically. Yeah, you can have a look at the project DG sets. If you want to use it, we are on Umbrel and Raspberry. But yeah, in the end, the technologies of DLCs for me is good enough to depict that. But I mean, you can't, for example, depict a lending solution yet. You would have to need additional like scripting abilities if you want smart contracts to achieve that.
All right, Olga, what's RGB?
That's going to take me a while to answer. So long story short, RGB is one of the solutions for smart contracting, and it uses the idea of Peter Todd of client-side validation, which basically means that all the information on the asset on the contract is stored on the client side. This means that by default the technology is private because you are not forced to publish all the information out there anywhere. You need to anchor it to the main chain, but you still do not need to reveal all the information on it. You do not need everyone's approval on the asset and everything like that. Also, we make it, and this makes it scalable too. And we also reduced a lot of work that had been done by Blockstream with regards to confidential assets, confidential transactions. So thank you very much. It was extremely helpful, and yeah, that's what we do.
Adam, I think you're here to represent simplicity.
Yeah, so I mean, Tiro is using the Liquid opcodes for some very interesting things, and that itself has gone through a couple of iterations. So there's a more recent kind of version 2 with, I think, 30 additional opcodes, and they provide, in addition to the check-sig from stack and cat, lots of introspection opcodes and iterative hashing opcodes, so that it's sort of more convenient to construct the information and to hash it without needing to construct a big string first. So you can hash the string directly into the hash, which is usually what you want. So there's sort of helper functions to make it more convenient, to make covenants and to overcome some of the limitations of opcodes relating to the maximum size of a script. And then simplicity is a separate thing. It's a kind of soft forkable, next generation Bitcoin script. It was first talked about, I think, in 2012 or something like that on IRC. It's originally was talked about as MAST. So the full idea for MAST is actually simplicity, which is to build a next generation scripting language that's lower level, UTX, still in the UTXO model, but to make Bitcoin script self-extensible and to do it in a way, sort of a low level kind of assembly language or microcode level that's much more low level than Bitcoin script, so that you could build new opcodes in a kind of next generation Bitcoin script itself. And so the example I'd use is that if Bitcoin had simplicity today, something like Schnorr, the Schnorr opcodes could have been implemented directly in simplicity without needing a soft fork. So in a sense, if there is hope to finally ossify Bitcoin, simplicity is probably the best hope for that, because it allows you, it could be the last soft fork in effect.
So does simplicity is it a soft fork because it uses the op-nop codes, or why is the soft fork?
I think it could be, I mean, it's just a new script version, so it could be a new SegWit script or a new tapleaf script version. And it's much more low level, so the operations are basic. I mean, it's called simple because it only has 9 operators, but this is in the sense of like in a machine code or binary logic, you know, you've got different kind of bit level operations. So it's operating on bits, and then you construct more complex things using those bits, like, you know, a 8-bit adder, a 64-bit adder. And there are libraries all the way up to, you know, elliptic curve multiplication, hashing, but they're all formally mathematically defined and provable because this language is sort of formal logic defined. And so you can make proofs about the correctness and equivalence of code with these, and prove things about, you know, the semantics, the maximum runtime, the maximum memory consumption, about programs. So it becomes possible to have high confidence in the behavior of programs, and while adding sort of complexity, so that you can extend Bitcoin script and write new opcodes from scratch.
Can I maybe ask a question for Adam?
Yeah, go ahead. Yeah.
Just like, how do you see the adoption of Liquid moving forward, also in respects to like eventually maybe Bitcoin also being extended with certain opcodes? Like, and how do you see Liquid like evolve in that? Because maybe as like a short background, like we went away from Liquid because we were just not sure how adoption would be driven, you know, like would we find users that we can onboard onto Liquid before, you know, they can even use our product. So yeah, maybe you can also say something for that here, I don't know. So we were like, okay, if we can do it directly on Bitcoin, why not go directly on Bitcoin?
Yeah, I mean, there's been some track record over the last, 5 years or so of opcodes or capabilities being on Liquid that later came into Bitcoin. So I think CLTV was one, SegWit, even though it wasn't a soft fork, it was a kind of, the Liquid chain started with SegWit directly implemented, right? And so the concept is like maybe the Covenant opcodes will make it into Bitcoin, and it doesn't have to be direct, right? It could be informed by. So, the things that Tiro builds with Covenants, maybe he decides it would be better to do it in a different way, and then Bitcoin learns and does something, a different variant of it. So I think Liquid can just, innovate faster, try new things earlier, and have a developer experience of learning from them. And, the best parts of it later make it into Bitcoin. So it's generally going to be possible to, do more bleeding edge things with it. And of course, it has direct support for different assets. So that enables some things that are going to be hard to do without oracles on Bitcoin. But I mean, certainly the hope for simplicity, simplicity is both a Bitcoin project and a simplicity project, a Liquid project. And there are branches of Bitcoin with simplicity, like a developer release. So it's really a kind of next generation. But I think the lesson from, watching SegWit and then Schnorr signatures were also in Liquid first. To see how many years that takes. It takes quite a few years for new ideas to reach maturity and have enough experience on Liquid until they get potentially adopted by Bitcoin. So I think it's just a long time frame. And in terms of Liquid adoption, that's really down to, users and interesting, compelling use cases being built. But, as with Volpem and Sideswap and Bitmatrix, there are many more innovative applications built on Liquid now, which add real value for traders. Like, it's much safer to use. While Liquid is less decentralized than Bitcoin, and you should always do cold storage on Bitcoin, with Liquid it's much safer to trade there than on an individual exchange, because the pegged Bitcoins are ultimately, in a hardware-assisted multisig from many exchanges. And so, the prospect of one of them going rogue doesn't really impact the security much of Liquid.
Olga, you want to?
Yeah, I wanted to ask, so if we think about some sort of a roadmap for simplicity specifically, what time frame can we be talking here? Years, decades, months? Because it's really a huge thing and it can bring a lot of value.
Yeah, I mean, so we hope to have, there are developer releases. You can look at the active development. There are a lot more people working on it now than, a few years ago. And so we hope to have something in Liquid, this year or early next year. But the timeline for something of that complexity to make its way into Bitcoin is presumably like 5 years kind of range. That was certainly the kind of time frame that it took for Schnorr signatures to go from liquid to Bitcoin. And interestingly, Bitcoin has a slightly different version with some improvements that weren't known about or understood fully at the time.
All right. Well, speaking of time frames, our 20 minutes are already up, actually. So thanks for being here, and an applause for our panelists, please.
Thank you.